Okay, so yes, as was introduced, my name is Ashton Eves. I am a senior land scientist at Hawke's Bay Regional Council, and yeah, I've been part of this project since I started back in March of last year. So I'm going to give an introduction to what has happened over the last couple of years, and then we'll have each one of the speakers of this put their piece forward of what they have been doing over the last 2 years. Okay, so a bit of an introduction to the project. So it is a collaboration between Hawke's Bay Regional Council and Manaaki Whenua Land Care Research. It started back in 2022 and under the previous land scientist, Barry Lynch, and the purpose of it was to maximise the benefit from the acquisition of LiDAR that we did back in 2020. So yeah, we flew regional LiDAR for the whole region, and we were looking at how we can better utilise the information we had gathered. So therefore, some applications were put forward, and we looked at building a partnership approach to look at investigating these. So it ran for 2 years. It cost each organisation $500,000 each. And for HBRC, it focused on implementations of science into policy and management. And for Manaaki Whenua, it was looking at geospatial research gains. The research splits into different tools at the landscape analysis scale. And there'll be 4 presentations, as I mentioned, to follow with each of the leaders of the sub-projects. So just a quick introduction to the application. So these are first looking at improving understanding and management of erosion with LiDAR. The second one was improving land characterization with LiDAR. Third is vegetation mapping, and fourth is ecosystem services mapping. As you can see here on the slide, there's just some quick snips of, the regional scale at which these different tools operate. So I'm going to talk briefly about how the council is looking to implement some of this information. So I'll break down each one of the applications and tools, and then our experts will jump in. So for the erosion management, it's being used to aid catchment advisors to identify erosion-prone land and target poplar pole planting and riparian planting. It is also being used for identifying land vulnerable to erosion in plantation forests with an eye to afforestation for areas most at risk. It can also be used at council for estimating catchment sediment loads using the SEDNet piece and the possible impact on receiving marine environments. The land characterization work looked at defining intensive winter grazing constraints from the slope layers, and this was done at the farm scale. We also had an update to our land use capability maps based on the new LiDAR and the new slope, particularly looking at LUCs 1 to 4, the arable land. And this will help to inform the spatial representation of our highly productive land areas, which is an ongoing process with our planning department. The vegetation we're using for getting a better understanding of where the forest cover is and identifying priority biodiversity areas. We've also updated the land uses for plantation and forestry and horticulture. As you can imagine, plantation forestry is quite a dynamic beast, and so, for example, the LCDB is not quite up to date with that, whereas the 2020 LiDAR gives us a good snapshot of what kind of forest cover we had there. And then obviously, each iteration will gain more knowledge. Similarly, carbon sequestration, because we have a good map of the vegetation, we can see how it grows over time. The fourth tool was looking at ecosystem services. So this is the proportion of runoff and nutrients retained by the landscape using scenario analysis. Also looked at the amount of biomass carbon stored in trees and air pollution removal. Looked also at ultraviolet protection and shade provided by the tree canopies. And from this, it can derive a score of landscape aesthetics, which combines scores of the physical landscape and the relative attractiveness of different land cover types. So that's a brief overview of how we are intending on using or are using the products that we have received from Manaaki Whenua. Obviously, there'll be more to come, and yeah, use cases are plenty. So we'll move on to Hugh now, and we can look at number 1, erosion.